on my way to you. But it's mostly.
Come on in, come on in.
See you.
Come in, everybody.
More than anything else. Sit down.
It's so good. Come on in. We're going to kick off in a minute. Come in and sit down. We're going to kick off in just a moment. All right, come on in, folks. We're going to get started while the last people come in. Okay. All right, alrighty. Welcome to Cloud Native London. I am your host for the evening, Cheryl. We are a strong, open, diverse developer community dedicated to cloud native platform and technologies in London. This is me. I'm your host for the evening, Cheryl. You can find me online at ocheryl.com. I work for ARM as a senior director. Tonight we have 3 talks for you. The first one is the evolution of Grafana Alerting. And then 7:15, we have when they go high, we go low, hooking Libc calls to debug Kubernetes apps. Then we're going to take a 15-minute break, come back at 8 o'clock for Make Developers Fly, Principles for Platform Engineering. And then we're going to wrap up at 8:30 and go to the Conductor Pub, which is just outside this building on the left, if you want to keep talking. Sponsor for tonight is Grafana Labs. So Josh, would you like to say a word?
I only have one announcement to make, and is that I forgot my stickers, so I'm not going to have any. Sadly, it's all bad news. But you know, it's like, yeah, Grafana. I'm going to talk a little bit about alerting later. Enjoy the meetup, and we're hiring, which is mandatory.
Thank you very much. Thank you to Grafana Labs for supporting us tonight. Okay, now a little bit about you. Please grab your phones and you can go to this link or use the code. You don't need to download anything. We're going to do a little bit of live polling to find out about you and about how you use Cloud Native. Okay. All right. I think everyone's got it. First question, is this your first time at Cloud Native London? I see a lot of people have already voted no. A couple of yeses trickling in. We also are live streaming to YouTube and to Twitch, so there's probably a few people online joining us as well. Looks like all the yeses are creeping up. Are we going to hit 50% yes? Maybe not. Oh, almost. The poll for tomorrow's election. Oh, we're not going to step into that. Okay, looks like we have about half new people and we're returning. So either way, you are very welcome. I'm very happy that you're here. Next question, what's your job title? So pick whatever's closest to what you do. So architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or other. SRE and DevOps obviously showing up pretty strong tonight. Couple of good spread actually, good mix over backend developers and architects and engineering managers too. All right, let's go to our questions, and these are submitted from our speakers. How familiar are you with Grafana Alerting? I use Grafana Managed Alerts. I use Data Source Managed Alerts. I don't know what either of these are. So, a good number of people saying they don't know, and a good number of people actually already using Grafana Managed Alerts. Josh, this is your question. So, how do you feel about this answer? You came prepared. Okay, looks like at least 50% of people will find out. We'll learn something from tonight, at least. Our second question comes from Tao, who's online, who's our second speaker. So in your organization, how long does it typically take from the moment of a code change in the IDE until the new code runs in staging? So no time, it happens instantly, less than 5 minutes, between 5 and 30, between 30 and 1 day, more than 1 day, or anything else between I don't know and panic, I think. Oh, okay. So sort of quite people between 30 minutes and 1 day. So 28% of people say more than 1 day. Tao, are you on the line? Can you hear us?
Yeah, I'm here. Can you hear me?
Tao, are you there?
Yeah, I'm here. Can you hear me?
Oh, okay. I can see you speaking, but we can't hear you. Okay, we will fix this in time for your talk. All right, sorry about that. All right, let's go to our next question. What is your experience with platform engineering so far? You love it, it's nice, it's mildly disturbing, or it's horrible, or not had any? Okay, this question comes from Alexander. So, 50% of people saying it's nice. 23% people saying they had none at all. What were you expecting with this? When you
most people didn't have any.
expecting most people to not have any experience? Well, we've got a majority of people saying they do. Most people sort of mildly happy, I think. But we're interested to see what's the people who say it's horrible, why that's horrible. Okay. Thank you very much for your contributions to our questions tonight. I'm going to take a selfie for social media. I think let me do it from this corner if I move the whiteboard. Everybody smile, wave. Try to take a selfie this way. All right. Thank you. All right. And if you want to come and speak, we are now booking for 2025. So please sort of think ahead. You can also sponsor us, help us out with pizza or promote your own events. Go to cloudnativelondon.com for all the information and where to submit. And that is it. Do keep that polling up because we'll use the polls for the questions as well. And with that, I am going to hand over to Josh. So please round of applause for Josh.
It's gonna take a minute to set up, so give me 1 sec. We should be able to do this. Let's say this. This. Hello, 1, 2. Cool. Perfect. Good evening. Welcome to the evolution of Grafana Alerting. We're going to spend the next 30 minutes together. We might as well just like get to know each other a little bit better. I'm Josh. Actual name is Josue, but like I like Josh a little bit more. It's more English friendly. I'm a principal engineer at Grafana Labs. Up until a week ago, I used to lead the alerting team. So I used to be the alerting guy. But now I've moved into our metrics database again, which is one of the squads that I actually originated from, working on a cool new project that we're putting together in Grafana Labs for the next year. I'm also a Prometheus maintainer and one of the main maintainers of the Alert Manager as well. So yeah, make of that what you may. My socials are down there, so that's my GitHub and my Twitter. If you want to know more about alerting or things, you can give me a follow. So I'm going to do another show of hands in order to try and level up the talk and try to see how much the basics do I need to go through. Who here uses Prometheus? Who here has an alert in Prometheus? Who uses Grafana? Has an alert in Grafana? Who here uses MetalBear? So Grafana MetalBear. Less hands in there. I'm not even going to ask about alerts in there. It seems like no one does. Okay, cool. So I think we should go through some of the main concepts because I'm going to talk about a lot of these things, and if you don't know what they are, I don't want you to leave the room without that knowledge, right? So first, we're going to talk about what is an alert rule, and its definition of the queries that, like the system needs to evaluate periodically. An alert instance is, the set of labels that the rules will produce. So if you have a service, or you have 10 services and you write a query in one of your metrics databases that tries to query across those 10 services, for you to identify them, they would come with different labels and values, right? So an alert instance represent one set of those labels and values, or what we call a series in the Prometheus world, right? Alert evaluation is a single execution of the alert rule, right? So like typically with an alert rule, you would say, hey, evaluate this condition for a certain amount of time. If it holds for 15 minutes or 10 minutes, it's like, hey, this is what I wanted to fire. When we say alert evaluation, we mean one single evaluation of that, right? An alert, it's an alert instance, so like one single series that got delivered to what we call the alert manager in the Prometheus world. A contact point / receiver is where you want your notification to go, right? So like if I want my alert to go to Slack or email, right, contact point or receiver is what we actually refer as email or Slack, right? And notification is the thing that you get from the alert manager all the way down to your third-party integration, right? So this is actually the alert being delivered from one system to the other, which is the third party at the end of the day. An expression which is not really relevant for us, but like it's the language that Grafana uses in order to, define alerts, which you're going to see as part of the demo if we have time. Cool. Yeah. Do we need to get a little bit closer? Probably, right? Yeah. Okay, cool. Cool. So I'm going to start the history of Grafana with panel alerts. This started back in Grafana 4.0, so 2016. And the concept was really simple. You have a panel. You can't stare at it 24/7. I need to know when something in this panel happens, right? So you put a set of conditions in there. You get alerted. You get something that notifies you that something happened in this panel. Like, tell me when something happens in here. One of the challenges with that we immediately ran into is that people started running this in high available mode, which is like having multiple Grafanas, right? And then, like having your panels be in conjunction on each Grafana instance. And whenever one Grafana instance went down, you wanted the other one to pick up. And there was no way to do any of that. So people wanted to be running rules in high availability mode in Grafana. Turns out that this is actually a very difficult problem for alerting, as you'll see later in the talk. But we solve it in the simplest way you can imagine, right? Like we introduced this as part of Grafana 2.0, 4.2, 2017. And we use the database for that, right? So like we're able to know which Grafana was the one that notified you about the alert, save it to the database. If we see an entry there, we don't notify you from the other instances. Done. This clearly had some feature gaps. It worked great up until a certain point. But people wanted to push the system further and further, right? So like we kept getting feedback at the time about, hey, can I use template variables? in my alerts. So what we call the problem of multidimensionality in the alerting land. People wanted to have multiple alerts per graph. They wanted to use template variables, and this really wasn't possible. Like the system wasn't tailored to be able to do any of that, right? So like this is you having the multiple labels thing that I was just describing at the beginning, right? And then you having individual control over those single series, over those single alerts, right? So if you're querying your metrics database for a series that return you 10 different services, you wanted to route the different services to different teams. This wasn't possible in Grafana Alerting, right? They also wanted to silence the alert temporarily, so it was firing, but it's annoying me right now. I don't want to be notified about this. This wasn't something that Grafana was doing at the time, right? Another player came into the space around the same time, which was Prometheus, right? Prometheus came along with what we call the alert manager as his alerting solution, right? So it's split into two, kind of like a split brain problem. Prometheus would execute the alerts. One, it was ready to fire, it would send it over to the alert manager, and the alert manager would be in charge of, delivering it to your notification system. So this is like the Slack or the emails, right? It handled all the problems that we saw beforehand gracefully. Didn't require a SQL database to operate. It relied on the gossip protocol to communicate between different instances, as you can see here, right? So we actually introduced support for that within Grafana. So we say, hey, can we actually, connect Grafana and the alert manager so that people can send their alerts to the alert manager and they have the features that they didn't have before, right? Of course, this came with a very obvious problem, right? It's like now you need to run two systems. No one likes that, right? You need to run the alert manager, operate it. You need to connect it with the gossip protocol so they communicate between each other. Require operational expertise in order to be able to make it work, right? And people were not really loving the idea. They wanted to have all the different goodies that you have within the alert manager, which were the feature gaps that the product had within Grafana itself. And don't even get me started about the configuration pain, right? So like having to change two systems at the same time is like, as you know, it's a recipe for disaster. No one likes configuring two things at the same time. At the same time, the alert manager adoption was like steady as a rocket ship in terms of like how many people were using it. As you can see by the GitHub stars history, if we take that as any measure of adoption. The community seems to be using more and more. It's like we saw more people integrating Grafana with the alert manager, and we're like, yeah, well, the big question is, can we actually run the alert manager within Grafana, right? So like that way, you don't have to run an external system, right? We could connect the two things, and then you would get everything within one single system. Both systems are written in Go, so like importing one into the other was kind of like a simplistic endeavor. We wouldn't have to run under the hood two separate binaries for you. Everything would be just one single binary that you run, and you call it a day. Surprise, is exactly what we did, right? This is what we call unified alerting. You can blame me for that decision. We embedded the alert manager directly into Grafana in order to provide you with all the different goodies that you were requesting at the same time, right? Which was like, hey, can I group my notifications in a different way? Can I send this set of series to a team and this set of series to another team? Can I actually, control how often I want to receive these individual notifications? Can I silence things, right? So I thought it was a simple solution to all the problems that we came around. Surprised it wasn't as simple as I thought it would be. You can see we came up with the beta release in Grafana 8.0, not Grafana 8. Grafana 8.0 back in 2021. This was the same time we put it out there with beta. It wasn't ready. The community told us it wasn't ready for sure. But we knew it, right? We wanted to put it in front of people. We wanted people to use it, gather the feedback, and then try to prioritize how we build the whole structure from there, right? It's important to know that in this part of the history, there were other systems that were coming up. So we spin up our cloud offering for alerting, which relied on Prometheus alerting, not necessarily Grafana alerting, right? And we introduced the concept of memeer, which is our metrics database back in 2017, which was a way to evaluate rules in a multi-tenant fashion. This is a little bit deviating from the story, so I'm just going to touch it up there because I think it's important to know that 2020 was the year where we first released the Grafana Cloud Alerting, which is an entirely different alerting system from Grafana Alerting, right? So like, make no mistake, they're two different things. Grafana Cloud is our cloud offering. Grafana is the open source binary that you all know and love, right? One single thing, it was not enabled by default when you were in beta. You actually needed to enable this, right? We wouldn't want to disrupt people's systems, especially when it comes to alerting. So you needed to manually enable it in order to be able to try it out. The goal was simple. We wanted to create a single UI for everything, right? So like right within Grafana, you would be able to see your alerts from the alert manager, your alerts that you have within Grafana, your alerts that you have within the Grafana alert manager, to make things even more confusing, right? This is why this is why I've highlighted this picker right here, right? Because you can see, you can pick within Grafana what alert manager do you want to visualize for, right? So you have the Grafana, which is the internal one, and then you have others which you have connected directly in there, right? But yeah, as I said, the goal was simple: one single UI to configure everything, one single UI to see everything, single pane of glass, add as many alert managers as you want, see it all within Grafana. We started building, we continue building the same promise of unified alerting. As you can see, we made it the default and Grafana 9.0. So this is 2022, right? The moment you open up Grafana, this is what you would get, was a new version of alerting, no more legacy alerts. And we tried to build that feature gap between 8 and 9, right? So like the main complaint at the time was like, hey, this isn't as easy to use as I thought. I need to retrain all my staff into understanding this whole new mental model of alerts. The whole alerting system was simple. I don't understand it. It's like, can you make it as simple as it was in Legacy? So we did a lot of that between 8 and 9. In Grafana 11, which we just released a couple of weeks ago, we completely removed legacy alerting, right? And this was a big step for us because at that point in time, we felt confident. Okay, now the system is easy to use, as easy as the legacy system was. We know for sure that it's a lot more powerful. So let's remove that entirely so that we don't have to deal with legacy alerting. This was a big milestone for us, and I'm really proud of being able to, remove legacy alerting and make our users happy in there. Coming into the full timeline, right? It took us basically 3 years to go from the beta in Grafana 8.0, 2021, all the way to the legacy alerting removal and making the unified alerting the only system that you could use. So this was really big in terms of what we have for Grafana 11. So with Grafana 11 in mind, I want to walk you through some of the big things that we have put in Grafana 11 that I think you'll love if you use any form of alerting here. We introduced a way for you to preview your notifications, and this was really complex in your heads, right? Because you needed to find a way in which you can edit the template, you can integrate it with data, and this is all done at runtime within Grafana. So we settle on this approach, which is on the left hand, you define your template. On the right-hand side, you can add the data that you want your template to use. And more importantly, we allow you to select specific things that are fine within your system as well and use them as example data. So let's say that you have an alert that's firing. You don't like the way that it was rendered in Slack. You want to modify that because it really doesn't look good. You can select that particular alert as the template example data, and then modify the template in order to see how it looks in the middle window, as you can see here. I think this is really cool and people are going to love it. The single most complaint that we got was about the routing of notifications. So in legacy alerting, when you wrote your alert, you could select, hey, I want this alert to be delivered to Slack, and that's it, right? It was really simple to use. People will get started on it right away. With unified alerting, you needed to understand this whole complex routing system. So we made a change to that, what we call simple routing within unified alerting. So before you had the 3 parts, now with unified alerting, you have the 3 parts, which is the alert rule, the notification policy, and the contact point. So you write your rule, then you select your contact point, or you introduce your contact point. So this is your Slack configuration that you would put which channel it's going to go, right? Like your API keys. And then you write the notification policy, which is saying, hey, when an alert with this label is fired, send it to this particular contact point. We have completely eliminated the middleman. And you can now say, hey, my alert rule, which I'm now creating, you can send it to a particular contact point by selecting it directly from the alert rule screen. I'm going to show a small demo on this if I have time at the end, because I think it's really cool. And the way that we have designed the feature as well, I think people are going to love it. You can do the complex things in here as well, right? So like you can select the kind of group timings that you want to have. So how often do you want your alert to be evaluated? How often do you want your alert to be delivered after I've delivered you the first time? How long should I wait before I make it before I deliver it the first time around? You can actually select all that right here from this screen. We have completely redesigned our contact point view, right? So this is where you would configure your email or Slack. So you can see that if you have, for example, an email integration, I can show you the email directly on screen where it's going to go. I can show you the last time it was delivered. And I can show you how long it took to, deliver that notification over there, right? So like if you could actually tell if your downstream system, your third party, is being slow or not, right? We have completely redesigned the alert rule overview. So now we have this really easy to use tab navigation with all the information you can have on one hand. We actually show you the different tabs in here, which you can click, which shows you the history, which shows you the query that you're running, and show you the alert instances that are currently firing. In here, you can see directly the queries, which wasn't possible before. Now you're able to see the queries in there, and you're able to query them in Explorer if you want to explore the timeline of the metric, not just for the particular alert. And down there, you have the graph with all the series all in a single view. We hope that this actually makes people lives easier when they're on call. So now you have the rule if you're being paged for the particular rule, you can click on the rule detail view and you have all the information that you could possibly want in one single window in order to confirm that this is indeed something that's gone wrong. You also have all the different computations. So Grafana managed alerts are really powerful. They allow you to do all sorts of transformation on top of the alerting data. You can reduce, select the minimum, select the maximum, whichever way you want, regardless of whenever it's Prometheus, whenever it's SQL, whenever it's any other, data source that you can connect to Grafana. You can now see all that in the rules details page directly. So with that said, what's next for alerting, right? Like what's our North Star? We're far away from delivering our end goal, which is a unified system that encapsulates everything. It's like right now you still have to make the decision between, hey, should I use a Mimir alert? Should I use a Loki alert? Should I use a Grafana alert? What's the difference between them? This is why my my first question that you saw at the beginning of the presentation was kind of like preceding that, because most people don't really know the difference about that. And that's something that we definitely want to eradicate. That source of complexity where you need to become an expert in both systems in order to be able to make the right decision. It's not something that we want, right? We also have the problem of the multiple alert managers, right? So like, especially if you sign up to our cloud offering today, you would see that you have two different alert managers, one for Grafana and one for the external one, which is Prometheus based that we provide to you. It's like, what's the difference between them, right? Like, why should I have two? We want to be able to, but we want to make sure you don't have to make that distinction at the end of the day. And that's kind of like a problem for us that we want to solve. They're kind of similar, but they're configured a little bit differently. And we don't want that. We want single configuration for everything. We want to make sure that we ease all the pain away from you when it comes to that. And also rule evaluation, right? Like rule evaluation is different between both systems. If you're running Mimir, if you're running Prometheus, you're running a Grafana alert, the way that the rule is evaluated, the number of hops that it takes is completely different, and we don't want that. We want to be able, you pick the right tool for the job regardless of where the tool lives. So a big drawback, with that said, a big drawback that we have in Grafana today is the way that it scales, right? So Grafana is only able to vertical scales when it comes to alerting. So if you have, hundreds of thousands of rules, all you can do is throw more CPU and memory at the problem. You cannot horizontally scale. And we've started a project that it's now live in Grafana Cloud, not fully rolled out. We're rolling it out in phases. But we started a project in Grafana Cloud that allows you to do just that, right? Like if you're familiar with the way that or other architect or other databases work, it's a pretty similar architecture to the component we call the ruler. You can throw any number of alerts. You can horizontal scale the system to, you know, like global scale, whatever that means. And you'll be able to be just fine regardless of the number of alert rules that you have. We built this in a similar fashion to how other databases work, right? It's like you make the system pull all the rules together from all the different tenants that you might have, right? Then you distribute it on multiple machines, and multiple machines are able to take care of, are able to own a subset of those rules and evaluate them independently. So if you're running low on resources, you can add more of those components, and they will be, you know, distributed against amongst all of them. Cool. As I said, this is something that we have already built. We put it in production in 2024, so this year. And we're still stabilizing it. We're rolling it to Grafana Cloud right now, but it's not 100% rolled out. But with that said, I want to make a small pause because I want your feedback, right? Like if this is something that you want, if this is something that you actually use, that you would actually use within your organization if you're using Grafana open source, do you think there's any benefit on that from open sourcing it, right? It's not open source yet. It's something that is actually closed source, but you know, we would hope that with enough feedback and enough support, we were able to make the time to pack it and offer it back to you. So if this is something that you're interested in, like tell me or let me know in the comments or in the questions in any way that you can. Questions, I'll take some questions after. Cool. So with that said, what's our North Star, right? So as I said, we want to be able to give you less integrations, right? So like in the two alert managers, the receivers or the contact points that behave in a similar way, but the configuration is slightly different. We don't want that. We want to be able to, you have just one single place where you configure everything. We want to bridge some feature gaps that Grafana managed alert rules don't have. So they don't have a concept of recording rule, which is, you know, a way for you to speed up your rules. So instead of having to execute the same query over and over, multiple rules, so you can pre-compute the query and then use that pre-computed series as a result of another series. They don't evaluate sequentially, so you don't have that semantic of being to use the output of others. And in terms of configuration, we want to make it compatible, right? We want to be able to switch from one to the other without any sort of input. Let's say that you're now running, you have selected Grafana Managed Alert because this is what you thought at the time that was the right decision. If you want to switch that to a data source managed alert, you should be able to make that seamlessly without any sort of hiccups in there or any sort of migrations. And we want to be able to make the distinction, you know, pretty clearly between them. So like if you have a Prometheus or a Loki alert, there's no difference between that and a Grafana managed alert rule. You can just pick the right one for the job. We're doing this with basically two projects. So the first one is we're unifying all the alert managers. It's something that's happening today. This is actually open source as well. So we're taking the Grafana alert manager and the MetalBear alert manager, and we're putting them under one single component that's open source for you to use as well. So now if you want to connect your Grafana directly to the MetalBear alert manager in order to have all your alerts in a single place, you can do so. And you no longer have that distinction that you need to select, hey, can you select this one for this one and select the other one when you want to look at one system or the other. So yeah, no more of this, basically, one single system. The same thing for the rule evaluation cycle. We want to be able to combine all the different things into just one single ruler, but this is something that will come out eventually. We haven't even started on this. This is more of like an ambition that we have of making it work like that. But for now, what we're going to concentrate on is making sure we bridge the feature gaps between the two systems and then eventually unify them to make sure you don't lose anything in between. And there's very little migration to do between the two systems at the end of the day. And with that, you know, become one true unified alerting system, which is what we wanted from the very beginning, right? Right now, what we've done is try and combine everything into a UI as opposed to do an actual unification of one single system to run. It's more of bring all your systems and you'll be able to visualize everything in one single application as opposed to having one single system for all your evaluation and all your alert delivery at the end of the day. And yeah, thank you. How much time do I have? Do I have time for a demo? 10 minutes? Yeah, I think I'm gonna do Q&A instead of demo because like, yeah, sure thing, yeah.
Right. Okay. Alrighty, thank you very much, Josh. We've got a little bit of time for Q&A, so we can either use this orange cube or you can type in some questions for Josh. So, anybody want to start? Oh,
Working? Hello?
Is it-
One,
oh,
two?
you want to go that way?
Want me to throw it? Yeah?
Yeah.
It works? Yeah. I know that you are, the focus now is on alerting consolidation, but, and I know the alert, Grafana on call SaaS model approach, and also the open sourcing. We tried, I would say 1 year or 2 years ago, like a POC, but there are plans to maybe after you get the alerting done, move towards the notification, or notification with plans is to still on the SaaS approach, because I would say the dependence and the costs in bigger organizations to pay for an application like PagerDuty or the other ones, like what we pay for them, I would say is shameful today. And which are the plans around that, or if there are any?
Do you mean open source or do you mean in cloud?
I would say something that's reasonable. At the end of the day, I would say, as an end user, I would say open source, but I know as a company, you have to make a commercial decision. But if you have a roadmap or something that you could share, I'll be happy to hear.
So we do have an on-call product, which I think you mentioned, right? Yeah. Which is Grafana on-call, right?
Yeah.
You can integrate it right now in your open source stack and it will work. The plugin that we use is also open source, I believe. So we have open source every single piece that we use in our cloud stack is already there for you to use.
Yeah, but I think maybe I'm a little bit outdated, but when I tried last time, I think a year and a half ago, was probably not ready to use.
Yeah.
I don't know how it is today.
I think this is already in set to use. It's like we're actually selling this to our customers. I would argue that, yeah, you're right, about a year and a half ago, it wasn't necessarily ready. It wasn't well integrated in between pieces. But right now, it is, especially in our cloud products. You're able to just automatically say, hey, when I create this alert, send it over to on-call, and you would get that even in your free tier. So like, even if you have a project that you have started you're eager to get started, a pet project of sorts, you're able to use our product in order to be able to test it right now.
Okay, thank you.
Any other questions? Yeah, so the question is the accuracy of alerts with less false positives with the cloud platform in comparison to the previous ways? Is the accuracy of alerts? I'm not entirely sure what that means. Is there someone from the audience here that can clarify the question maybe? Or yeah, happy to. You wanted to say something, or should I go? Okay, cool. So we've introduced a concept of, which is Prometheus calls keep firing for, which is how long do you want the alert to be sustained before it resolves? That's one way in which you can handle false positives, right? So like you're able to say, hey, only clear this condition if this other condition happens, which wasn't there before. There's also the knobs that you have within Grafana. So within Grafana, you have 2 knobs, which is don't alert me if this alert gets no data. So let's say that you're alerting on your temperature going about 40 Celsius, right? If we suddenly lost connection to the database while executing the Grafana manage alert, Grafana will tell you, hey, I don't have any data in order to be able to execute this alert. You're actually able to tell Grafana, hey, if this happens in the middle of my alert evaluation, treat it as if it was okay to begin with. So that's another way in which you can reduce false positives. And you have the same knob, but for errors. So if suddenly your monitoring system went completely out, right, you can alert or not alert on whenever we weren't able to communicate with the monitoring system, with the underlying database that you're using your alert role. So we have I know of at least those 3 mechanisms in order to be able to reduce false positives as a whole. They're all open source. Cool. You can throw. I think I can throw. Let's see. Appreciate it.
I actually just set that up, and I was wishing for having a okay, wait for, I don't know, 5 minutes and then alert me anyways if there are no data. I think that's not possible. It wasn't apparent to me that it's possible.
You're right, but we fixed it. This is an argument that we have internally for as long as time, right? Where I was against it, and some of the other members of our team, they were pro-choice, that kind of choice, and I was like, no, it's going to make the system a little bit more complicated. But eventually, we got enough requests that I just sway the other way, right? It's like it wasn't possible before, but with Grafana 11, it certainly is. You're now able to define. That's the reason why I lost the battle. You're now able to define, hey, if I get no data, instead of just being the single instance, if I get no data continuously for 5 minutes, only then alert me. So yeah, we put it in Grafana 11.
Lovely. Thanks.
Cheers. Interesting. Yeah.
I think we're done. Yeah. All right. Round of applause, please, for Josh. Thank you very much. Oh. Let's sneak one more in just because we've got a few minutes. All right. What level of granularity can you gain from FAS?
Understand the question. What level of granularity can you gain from FAS? FAS
Function as a service.
functions as a service, right? So like, I'm not sure how to answer this question. Does it mean from an alert to like, you can actually monitor your FAS if you're using something like, let's say that you're using Lambda from AWS, you can use CloudWatch in order to monitor your functions, I believe. And then you can write a Grafana alert that uses CloudWatch as a data source in order to monitor your functions. But like as long as you're instrumenting your functions in whichever way you may want, you should be able to create an alert from them for sure. Yeah.
Thank you. Thank you very much. All right. Okay, Tal, let's try this again. Could you unmute and see if we can hear you?
Yeah. Can you hear me there?
Okay. Can see you but can't hear you.
Okay.
All right. We're going to swap our third speaker in with second speaker, if that's okay, and we're going to try and fix this at the break. So sorry to throw this on you so quickly, Alexander. Yeah, if you wouldn't mind, I'm going to switch over to you.
Sure, just give me like okay.
Okay, looks good. Thank you very much. Please welcome Alexander.
Okay. Then let's get started. So my name is Alex. I'm from Germany. I work at Abreu, and I do a lot of platform engineering, automation, CI/CD, all that stuff. And yeah, let's look into the principles of platform engineering that we came up with, and how to make developers fly. And for sure, it contains AI, because what doesn't today? Okay, so hands up, who's a platform engineer today? Or here? Oh, 1, 2, 3, 4, 5, 6. Oh, wow. Okay, cool. Lovely. So let's see what you have an input for me. Okay, so what happened so far? There was the developer and there was also the operator. And well, they had shared value chain. They want to plan, code, build, test, release, deploy, operate, monitor the software. That's the whole value chain that you build as some kind of application. And well, apparently there was some wall of confusion between them. Oh, it's a little bit late. Okay, so they had this wall of confusion between them, and the reason is one part is actually measured by the frequency of deliveries most of the time. And the other part is actually measured by the reliability of the system. So pretty opposing goals. And this led ultimately to downtimes and poor response times, and as an ultimate problem to the stagnation of the value chain. And yeah, apparently it happened to just throw the software over the fence. I don't know if that's actually an English phrase, but we say it in Germany, so. Okay. Yeah, the definition of DevOps is we want to improve the method of how software development and administration is done. We want to be efficient in a collaboration in development and operation. We want to have shared incentives, and we want to improve the quality and speed of development and delivery to have some kind of cooperation between these teams. And then 2006, Werner Vogels came up with you build it, you run it. Okay. Is my Wi-Fi bad? Okay. So I see it. You don't? Let me try to. Oh, Zoom is reconnecting. That's bad. Okay. That is not good. Okay, give me a second. I need to reconnect. What the hell? Okay, here we are. Okay, so we were here. All right. So then Werner Vogels came up to 2006 and said, okay, you build it, you run it. That's like the start of DevOps. And that's where they said, okay, we have to improve the process on how these two work together. Back in the days, oh, come on. That's nerve-wracking. Sure, do you know something that I can do? Okay. Yay! Okay. You can. Okay, just give me a second. I will try to reconnect like from the Wi-Fi. I hope this will fix it, maybe. Yeah, it's okay, last try. Yeah, thanks. Okay, last try. Yeah, so what was back then? We had cloud, we had infrastructure as code, CI/CD. Then one of Werner Vogels came and said, you run it, you build it. And well, the curve went up and up and up. And there was a lot of complexity added. We have microservices, Kubernetes serverless, GitOps, all that stuff. And actually, it's not anymore a simple kubectl apply. You have to be secure, compliant. You need to integrate different things. You have to be reliable, scalable, all that stuff where you have to look at and where you have to have a solution for. And yeah, that's why we have platform engineering. We have platform engineering because we want to have some specific team, a specific role in the company that provides some kind of application platform that all the teams, the development teams, can use, and they use that to accelerate their application, the development flow. Because yeah, it's still DevOps, but you have one single platform where you can run on, and it's managed for you in many parts, and you have some abstraction that you deliver to the developers, and these developers can actually use this IDP to have some easy setup, and it has all what I said before. Like everything that you have here, it's built in the platform, and developers just can use it. So still DevOps, but you want to have something that's reusable and that matches your organization. If we put this in a picture, it's basically you have the developer, you have the application that this developer wants to deploy. You have the platform engineer that's helping, and we have just a single rope that is attached to that kite, and we get it fly. Just with that single rope. That easy it should be to deploy and maintain your application. That's our goal as a platform engineer. So if we look at what does an IDP need, is not just the managed services. It's many things more, because this is basically some kind of product that you offer internally to your company. So what do you expect from some kind of product that you offer? You want to have some tools, templates, golden paths, best practices, training, docs, all that stuff that developers need to use your product. And that's what you need to deliver. And in the end, what will it bring to you? Less tickets. You can focus on building the platform, and it will just be easier for everybody. And what do the developer teams have if they use your platform? They have a secure, reliable, performant, cost-optimized, sustainable, and excellence platform. So they can use it on self-service, they can reduce their cognitive load, and they can focus on the product delivery, and they don't have to mangle around with all these problems that, I don't know, Kubernetes, for example, has. So it's not just an infrastructure thing, it's way more than that. Okay, let's have a little detour to platform engineering and AI, because I will try to keep this short. But yeah, AI is everywhere. So why not approach AI and the problems that you have with products that use AI the same manner we try to tackle the normal default Kubernetes IDP. So you have some challenges. You want to have some control over what the people use. Back in the days when there was Azure, Google, and the cloud native era started, everybody was using everything, and now many companies try to consolidate into one single cloud platform, usually. That's what I see. So you don't want to have this uncontrolled growth. You want to use one single instance, kind of. You want to have the cost control, or a problem is the cost control. You want to capsule complexity, so the same idea as an IDP. You want to increase the speed, or you have problems with the speed, depending on how we phrase this here. And yeah, you need to be compliant. You want to have some kind of knowledge hub. And yeah, what's like new, or what's also an operation challenge, is you want to have access to your data lakes. So you want to have a single point of entry to your data lakes. And I mean, data lakes is not something new, and we all know what the challenges are here. But especially for AI and RAG, you want to have one single point where you can access that, where you can access your knowledge of the company or whatever knowledge you need to process. Okay, I try to differentiate when we look at an AI platform into 3 different levels. That's like the low level. We have some people that know what they're doing. They have the APIs they can directly access. Then they have I can imagine some kind of medium level. So you have some API for doing your RAG, and you provide some UI components, so it's easy for you to just use it. So you have some kind of knowledge of using AI, but it's still some kind of abstraction in there. And what I also see here is the test framework. So testing AI and the responses of AI is quite hard. And what you really want to do is you want to test it for different metrics, like how nice is it, how good are the answers, are these answers correct, and all that stuff. And you can't test it by just applying a regex to it or whatever. The responses will always differ. So it's hard to do it by some kind of static code testing. And there's, for example, ragas. That's something you can provide as an service on your platform. And then there's like the high-level access where you have just some ChatGPT with the knowledge of your company for each employee, or some no-code solutions like you can use that ChatGPT, have some kind of system prompt, and then people can just use it and accelerate their personal work. Okay, possible components of such an AI platform are managing the quota, because that's like one of the problems right now. I think it will go away in future, but right now you have to look at the quotas and your scale. You want that testing and evaluation framework like Ragas as a service, for example. You need to have some kind of GPT as a service, because you need to route the request and you need to version it. You want to have RAG, so retrieval augmented generation as a service. So that's prepared for your developers, and they have it quite easy to use. You want to have some embedding as a service, some internal chatbot again, and what you also need is some kind of guardrails. So you need to have some instance in the end where it says, okay, this is fine and this is not fine, because you don't want whatever answer it is, or for which application it is, whatever it is, you don't want to be root or whatever, and you need to apply some guardrails. Okay, when we look at it from a high-level perspective, it would look like this. We have some kind of data lakes we can access, security modules built into it. We have the platform core, and then we can see these levels. It's more like a high-level idea of it. When we look into it, we have this large language model in the middle, and then the request will flow through it with all these components around it, and the agent flow, that's like the thing right now, that you let the LLM plan their own actions. So it's like it has to process the request multiple times. So you can build that into also. Okay, back to the good old Kubernetes IDP. Which principles and patterns do we need to build an IDP? Like every good presentation, we need some acronyms. So this is Redux. We want to be versioned. We want to be decentralized. We want to be user-centered. We want to be customizable, transparent, and we want to have it as a self-service. So why do we want to version our stuff? Well, it is some kind of product. It is some kind of software that we deliver, and it needs to be versioned. Developers are used to versions and different versions, changes in versions, so we should do this too. The easiest way to do that is actually with a Git diff. We have a patch and we apply it. Because what we want to do is we have one central template Git repository where we apply our changes, where we do our Git tags, where we do all our development in kind of. and then we want to take the changes and apply it to some other Git repository that is actually the instance of such an IDP. Yeah, so that's quite easy. But yeah, you want to do it that way. And yeah, very important is the end-to-end test, although it's maybe take some time to spin up some clusters to deploy it actually and so on. Yeah, but it's important. Okay, you want to be decentralized. You want to have some shared risks and some fast iterations because, yeah, if one has a bad time in the pool, everybody will have a bad time in the pool. It starts off with scalability. I mean, if you have a default Prometheus running there, it's like really hard to have, I don't know, 800 applications with each 20 instances to just run it with Prometheus. You need some Tanos or whatever underneath, and it just gets more complex. You want to keep it simple, so you don't want to have a multi-tenant platform. That's what you don't want. It's at so many levels, so hard. Then you have Docker. Docker is secure, but it's sometimes easy, especially if somebody has some vulnerabilities built in. It's easy to escape, and you just infect the whole cluster. Yeah, do multi-tenancy. It's like hard on a Kubernetes. You have RBAC that you need to deploy for the whole cluster. And that's like super hard to do on a big scale. Then you have a single point of failure. So if one, for example, it don't need to be that the whole cluster is down. It just can be that the load balancer, for example, just has one faulty rule deployed from one of the applications, and all the traffic is somehow going to that one application. So that will break all the other applications. So you don't want to even be able to do that. And then in the last point, you have the coordination. I mean, there are deprecations, CRDs that you need to deploy and all that stuff. And that's super hard to coordinate. And you always have to wait for the slowest one. So that's really hard to coordinate. And you don't want to have fun. In the end, you're just blocked. You can't move forward. So what you do is you have some kind of golden paths and some central Git repository where you can look at what you want to do. But the main infrastructure that's actually running an app developers teams, oh my god, and development teams infrastructure is actually like on their own managed. It's their own Git repository. It's their own infrastructure. Everything is just deployed for them, and even in multiple instances, because you want to have some kind of development, QA, production, testing environment. All that is just one instance of such a blueprint that you develop as a platform team. And yes, you need to have some kind of governance. So something needs to be built in there so that you can check that everything's compliant as you want it to be. But on the other hand, it needs to be open so people can collaborate with the central blueprint kind of, and they can put back or bring back changes that are useful for the whole company. Okay. We want to be user-centered. I already said it. You need to have a product mindset. Users first. You are a product, and you need to handle that IDP as some product. And what do you wish from some kind of product that you use? It should be, yeah, like a decent experience to use it. So what you want is you want to have a good developer UX. So a DX is very, very important. You need some user guide for it. You need some blueprints, some golden paths. So people should want to use your platform and you don't want to force them to use it. That doesn't work. You need to make them want to use your platform, and that's by helping them and by providing resources so they can help themselves. You want to have some scaffolding for typical use cases. Yeah, like build your own CLI and help them with creating different blueprints. I mean, you have these blueprints anyway, anyhow somewhere. So just use it, just automate it for the users. You want to have observability and GitOps just built in, so that's crucial. You need to have everything that's like everything that every application needs, like logging, metrics, tracing, all that stuff. It needs to be built in and just work out of the box. And as last step, if there is something that people will have questions. People always will have questions, so there need to be some kind of support, although you try to reduce with all the resources that you supply these questions, because it's just like taking time from your team. Okay, although you have like a very nice blueprint and you have a very nice golden path and you provide all the resources, and still there's somebody who wants to have some customization because not everything works for everybody. So how do you do that? In a Kubernetes world, for example, you deploy Gatekeeper, so you're sure that just the resources that you want to deploy are actually deployed. And what you can do with that, as in this case, we just say, okay, it's just traffic that's allowed as a load balancer, and you can't deploy anything else that has an external IP, basically. But maybe somebody else needs some kind of other load balancer. So you need to allow, or you need to be able to allow a specific other load balancer that you define. And that's possible with some code owners, for example, in GitLab, or I think also in GitHub, it's possible to have some code owners. So what we usually do is we have an infra folder where everything that the platform is running from, or that instance of the platform is running on, has in it, and it's just manageable by the platform team. So you have to create a merge request, and then you can merge the stuff that you want to change. And then it goes through the normal flow of, okay, somebody needs to approve it, maybe security, maybe just the platform team, whatever. And then there's the user space where the user can just use, can just deploy their application, whatever they need. Yeah, that's the usual way how we do it, or how we think of it. So what you want is batteries included, but changeable. I think that's from some guy from Red Hat. Okay, what you want to be also is transparent, because yes, we built some kind of abstraction, and that's what the core of an IDP is for. You want to build an abstraction that people can have less cognitive load, but still are able to run a secure application on a secure platform that's fast, and all the things that I said before. So sometimes it's actually hard to build abstractions that work, that give a cohesive language and a mental model that's useful, and that's a useful abstraction, but it can also lead to dangerous illusions. So you have to look at how you draw your abstractions, and also you always have to make sure that everything is open source, like internal of the company, because yeah, you need to have some inner source so people can always look into, okay, this is my repository, I have ownership of this repository, of this instance, what's running in there. You have the tag, you go to the central Git repository, and you see, oh yeah, that's the code of line that's That's why my deployment isn't working or whatever. So it's good to have these abstractions. That's what we make this for. But on the other hand, you need to be able to actually look into that abstraction and dig down and change it with a merge request for the next version, for example. That's what you want. On the other hand, it's like any other product. You want to have a roadmap. You want to have an issue tracker, and yeah, just like some kind of internal open source product that we have here. That's how we should treat it. Okay, and as a last point, we have self-service. It's super crucial that you are able to do this on your own as an app development team. Because what you want as an PE team, you want to have a huge number of platforms of IDPs that you run in your company. But on the other hand, you want to have like a small platform engineering team, like, I don't know, 5 or 10 people, and you don't want to have any manual tasks. Everything should be automated. Just like you know it from, I don't know, Azure, GCP, whatever. Usually somebody's not required to, I don't know, plug a cable into a server before your VM is starting or whatever. That's not a thing that shouldn't be necessary. So the instance is actually operated by the development team, and they have full control over it. That's important. They have the stake on that, not the platform engineering team. They just provide some kind of blueprint, and they monitor that everything is as it should be. But the stake has the app development team, but they are enabled to do it correctly and fast with that platform. Okay, so when we look into building blocks on how to build these IDPs, one example on how to do this is AWS Proton. This is a service where you can upload your templates, and then people can just use it. So basically what you do, you have the platform team, you put it onto the AWS Proton side, so it's versioned. You can upload the different versions. You have it decentralized because it's just a blueprint. It's just probably some kind of YAML or whatever it is. And then if you instantiate one, it will be created especially for you. It is also some kind of self-service because you just give access to the people and they can use it. And it's customizable. And yeah, therefore it's user-centered and transparent because yeah, there are these templates and you can just use it. Okay. Another example is Humanitech, but I'm not sure how up to date this is because yeah, they had some troubles, I guess, in the last time. And then there is Pulumi, for example. And what we did in the past is actually we just use Git. We use a lot of CNCF components, and yeah, then we just use a lot of Go duct tape to put it together and to automate all the things. And then it just works. And why do we do that? Or why did we do that? We want to have all, I mean, we build some custom software all the time for the people. And that's the same thing here. You can use some kind of tool that provides you with some functionality, but in the end, it's actually always something different that every company needs some specific tailored on their needs solution. And there will never be some kind of IDP solution where you say, okay, I take it off the shelf and I just go with it. That's never going to happen. So IDPs are always super specific for one company. And that's why this is totally fine to do if this is what you want to do, what you need. And yeah, I mean, there are a lot of capabilities that you need to do that. There are different methods, and well, just choose your ecosystem. Go with what your company needs to build your IDP or your platform from, because yeah, it's just custom to what you and your company has as a need. Okay, this is Alex. This is my software architect. This is more or less his presentation. So thanks to him for giving me his presentation and the idea. And also there is this cool dude from AWS. He worked with us back in the days as a product owner. And they both came up with these principles. So kudos to them. And yeah, I think that's it. And I rushed through it, didn't I? All right, no problem.
Thank you so much to Alex, especially for stepping up last moment. We are going to go to a break now. So if there are any questions, please find Alex at the break. Please come back for 8 o'clock for our third talk. Thank you very much.
Hello, hello, hello. Hello, hello, hello. Hello. Can he hear us, or can he speak, and then can we hear him through your machine?
Yeah,
Can you hear us,
I
Tom?
can hear you. Yeah, I can hear you.
Yeah,
Can
so
you
I
hear
can
me?
hear you through. I can, sorry, start video.
Everything working fine on.
Yeah, I can hear you through Zoom. So it's
the-
some connection here.
So the mic is working here, the
Yeah.
speaker out, so it's the out from this machine to up there.
Huh?
You don't know. I don't know. No, I don't know. I would need to.
This is on Stephen. Yeah. Yep.
But I mean, you can just go.
I'm going to mute this one.
Yeah. So you want to break it. AWS Proton, you want to have like this.
Stop my video so I don't show up weirdly there. Actually, I can. But yes, I don't think there's anything that you need now. So just get that. Just go now, I think. Okay. If this doesn't work, then let's figure out something anyway. Yeah. Well, if it doesn't work, then my is coming in.
Hello, hello.
Ooh, okay, yeah. Oh, we're hearing something. Okay.
Test. Can you hear me?
Testing, testing. 1, 2, 1, 2. Testing, testing. 1, 2, 1, 2.
Can you hear me?
Okay, Tal, can you say something?
Yeah, can you hear me now? Can you hear me over
I can
there?
hear you, but it's very echoey.
What about now? Does this work now?
We can hear you, but there's some echo.
Is it? Oh, your mic's
I'm on.
Uh,
Tal,
do you
can you
think,
say something?
yeah, do you think the echo is on my side or?
Say something again.
Yeah, can you hear me now? Do you think the echo is on my side? Should I try to change my setup? Or actually it worked earlier, right?
I think that's okay.
Test one, can you hear me now? Can you hear me good? Test. Audio test one. Audio test, hello. Sound test. Okay, hope you can hear me now. This is an audio test. I can start saying things about cloud native. This will probably all be in a recording, so I should think about what I'm saying. Hello, test one. MirrorD is a cool open source project. You should totally check it out. Join our Discord server. You can send me an email if you want to get in touch. Hello, London. Are you reaching? Broadcasting live from Munich, Germany, all the way to London. Hope you can hear me good now.
Okay, I think that's good. Nope.
So Cheryl, you're muted in Zoom, so give me a sign when I should start.
Okay. Yeah, okay. I think we're good. All right, we're going to hand over to Tal. There is a bit of echo. Hold on. I don't know. The cube mic.
Having a good day with technology.
Maybe
I don't know.
maybe if you mute the Great Gatsby room.
Okay, we're just gonna go. Okay, Tal, over to you.
Okay, hi everybody. Hello. Welcome to this talk titled "When They Go High, We Go Low." My name is Zwick, and I'm a developer at MetalBear, where we develop MirrorD. So I'm right now in Munich, Germany, joining you virtually over there in London. Was a bit short notice, so couldn't be there this time, maybe next time. Yeah, I can't really see any of you. So if there's anything, any feedback or anything I should know during the talk, please maybe like wave to the camera that's somewhere over your heads. But yeah, let's start. So this talk is about solving a seemingly high-level problem, and that's the problem of cloud-native developer experience using low-level techniques. Specifically, we will discuss MirrorD, a dev tool written in Rust for working on cloud-native applications. MirrorD enables cluster-connected but local execution of cloud-native applications. And what that means and what it looks like will become clearer as we proceed. The high-level challenge MirrorD addresses is cloud-native developer experience. More specifically, being able to run cloud-native applications during their development. The solution MirrorD employs is at the operating system process level. So first, we're going to talk about what MirrorD is for. Once that is out of the way, we'll take a look at the cool low-level technical details of how MirrorD works. And then to wrap it all up, there will be a short live demo of MirrorD. So first, what MirrorD is for. Running the code you're working on is important and helpful while writing software. And with many types of software, that is a simple enough task. But with cloud-native applications, it becomes not trivial at all. I believe we should not abandon useful development practices because they are hard to implement with cloud-native software. We should develop the tooling to make them easy. But how do you run your cloud-native application while developing when the application accesses files that only exist in the Kubernetes cluster, or when it uses other services in the cluster over IP, or when you need another service to generate requests to your application? And besides, running your code often is good, and you might not want to spend time containerizing and deploying your application after every little code change you want to test out. So there are multiple existing approaches to solving this problem. They don't all offer the same capabilities and don't result in the same workflow. But there is, for example, remote debugging in the cloud. Some teams also try to just run everything locally on every developer's machine. The approach MirrorD takes is to enable local development with remote access. There are other tools like telepresence or Grafana that also belong to the remocal category. MirrorD works on the process level, not on the machine or container level, like some of the other tools, which results in a different workflow, and it also results in some nice technical talk material. Now, the idea is to have the optimal development experience for running the code. And that means for us, make it as simple as running non-cloud software. So basically, just a click on the run button in the IDE or a simple invocation in the shell. At the same time, we want developers to be able to run with meaningful data and realistic conditions, and also want them to just be able to utilize existing environments that they already maintain. With MirrorD, the developer can execute their code locally, either in a shell or in their IDE. And when the application accesses resources from the cluster, it gets the actual traffic and data from the cluster, even though it's running directly on the developer's computer. So developers can run their code very easily and do things like stepping through breakpoints in their IDE, but still take advantage of realistic cloud environments, like maybe a shared staging environment, all the while being non-intrusive and not changing the deployed applications in that environment. So that way, teams that use MirrorD get a much tighter development loop. So we've seen in the survey at the start of this meetup that for many teams, from the moment they do a change in their code, until the moment that code meets like close to realistic conditions, so maybe some staging environment, it can be more than a day. So in those cases where the bug or the issue only reveals itself once it meets realistic conditions, instead of discovering that issue several days later, developers can just run their code with MirrorD, but in the context of their cluster, and basically meet that issue directly, instantly. So MirrorD lets the software run in a simple process on the developer's machine and just adds a thin layer of transparent virtualization for connecting the application's I/O to the cluster. The way MirrorD achieves that magical effect is by injecting a dynamic library into the application's local process and hijacking some key operations made by the application. Which leads us to the next part, the technical details. So here we'll take a look at the key steps MirrorD takes in order to hijack an application's call and make them magically succeed, even when trying to access resources that don't exist on the system, but do exist on the Kubernetes cluster the developer is working with. So the first thing we need to do is to get our code into the process's memory. So now I'm speaking from a MirrorD developer's point of view. So when I say our code, I mean the MirrorD code. So we want to get that MirrorD code into the same memory space, into the same process as the user's process. And the way we do it is when a user tells MirrorD to execute a program, MirrorD executes that program, but first it asks the dynamic linker to also load our dynamic library into the new process's memory. And you might know it as the LD preload trick on Linux. On macOS, the relevant environment variable is called DYLD insert libraries. And MirrorD just adds the path of its dynamic library to that environment variable. And the dynamic linker loads our code into the new process in addition to that process's code. So now our code is there, but we need it to run. Just having our code in the memory does not mean it is executed. The user's application does not just call our code in its code, as it isn't and shouldn't be aware of MirrorD. So in order to ensure our code runs, we use another feature dynamic linkers offer us, which is what is sometimes called a constructor. Code that is placed in a specific section of the binary is executed on startup time of the process. So as mentioned before, MirrorD is written in Rust. So that's the syntax we're seeing here right now. There is a Rust package that offers an attribute macro that makes defining a constructor very easy. We just add that CTOR attribute above a function definition. So in our dynamic library, in MirrorD's dynamic library, we include such a section. And this allows us to run code on startup from our preloaded dynamic library. Okay, so far we have code execution inside the process of the user's application. Now there is a question, what do you run? But before we answer that question, just to make sure we're all on the same page, a quick introduction to Libc. So it's the C standard library. It implements useful low-level operations. It's used indirectly by almost every programming language. And when writing Python code, you might not be aware the code will result in calls to Libc when running. But if, for example, you write file.read in Python, when that code runs, at some point there is a call to Libc's read function or a similar Libc function. And this applies to programs written in most programming languages, but not to Go on Linux, which is why we had to do some extra work in order to support the Go on Linux, but this is outside of the scope right now. So programs typically don't directly include syscalls, but rather calls to Libc. And Libc in turn is where syscalls are made. And this makes Libc, specifically Libc calls, a good choke point for intercepting operations made by the user's applications. So now that we have code execution, what we do with that, what we execute on startup is code that utilizes Frida in order to hook Libc functions. Now, Frida is a dynamic instrumentation toolkit. And what that means is that it lets us manipulate the process's code while it's running. And we use it to hook some Libc functions. Now, here in this context, hooking means that whenever there is a call to those functions, our code is called. The way it works is Frida replaces the first couple of instructions in the binary code of a function with a jump to our code. And that way, whenever that function is called, the code from a function we define gets executed instead. So for each Libc function we want to hook, we write our own detour function with an identical signature and the C calling convention. That's a nice feature in Rust for interfacing with C. So we can define a function, write its code in Rust, of course, but give it the C ABI, C calling convention, etc. So note that code that we put in those detours doesn't run yet. The code that we run on startup is the code that hooks Libc functions. And our detour code runs whenever the user's application makes a call to the hooked function during its run. Okay, but what do we do in those detours? Inside the detour, we first check a configuration or flags the user past MirrorD and decide if this specific operation should be carried out in the cloud or locally. Everything can be fine-tuned. Users can choose to read some files locally and some in the cloud, or read in the cloud but write locally, etc. So if the operation should be carried out in the cloud, MirrorD sends the operation to a MirrorD agent running in the cloud. Now, MirrorD spawns the agent in the beginning of the run, and it is deleted automatically once the run is complete. And the agent carries out the operation, like, for example, reading a file or connecting to a socket in the cloud. The agent then sends the results back to MirrorD, Mirror returns the result back to the unsuspecting application that, of course, doesn't know about all of this and basically thinks to the extent the user's application can think that it runs in the cloud. So, for example, for reading bytes from a file, the application makes a call to Libc to read from a file. Mirror then hijacks that call, sends it to the agent. The agent reads from that file in the cloud, sends the read bytes back to Mirror, which writes them to the application's buffer. For the application, it's like the file just exists on its file system as if it is running in the cloud. At this point, you might be wondering how we access the deployed application's data, its file system, traffic, environment variables, etc. So first, we need to know where to get the data from. And for that, users can specify a target for Mirror. So that can be a pod, a deployment, or an Argo rollout, and optionally with a specific container name. Otherwise, Mirror chooses the container for the user. Now, the most common use case of Mirror is working on a new version of a microservice. In that case, the user would have a stable version of that microservice deployed in the staging environment of the team. And typically, that is the resource they would use as a target for running the new change version with Mirror. Now, the Mirror agent runs in a pod on the same node as a target's pod, and it joins the application's Linux namespaces. And it accesses paths relative to the container's process's root path. So to summarize, the agent runs in a container of a pod on the same node as the target. So in the end, it's basically just two processes running on the same Linux machine. Or at least that's the cool technical way to do it all ourselves. But ever since ephemeral containers were introduced, we also support using an ephemeral container in order to run the Mirror agent. And we'll probably be moving to make that the default. Ephemeral containers are meant to enable debugging a container. So by design, they get access to the same resources as the target container. And in case it wasn't clear by now, when I say we support using an ephemeral container to run the Mirror agent, that's nothing the user has to deploy or to configure or whatever. I guess maybe to configure, because all the user has to do in order to tell Mirror to run its agent in an ephemeral container is basically just pass a flag to Mirror when they run Mirror or set this value in the Mirror configuration file before they run. Now, when I talk about resources the application can access from the cluster, the main ones are network traffic, and this is both starting connections and accepting incoming connections, and also DNS resolution. Then there is file system access, and of course, environment variables. So zooming out a bit, we see that the main components are the Mirror binary installed on the developer's computer and the dynamic library it injects into the applications they run with Mirror. And in the cluster, there is the temporary Mirror agent. The dynamic library forwards operations to the agent, and the agent sends data from the cluster to the dynamic library that makes it available to the user's application, as if that application is just running in the cluster. Okay, so now after we went on this journey through some of the technicalities of how Mirror works, let's look at what users see when they use it. Take a short look at the time. Okay, seems like we still have 10 minutes that should do. Okay, so hopefully you can now see my IDE. Wait, actually, I have a slide for that. Okay, first, let's explain what we're going to do. So for this demo, we have a little example set up with some custom microservices written in Go. Those this one, like the IP visit counter, IP info, IP visit consumer. And then there's also Redis and Kafka services, all deployed on our cluster. And now we'll step through a scenario of a developer working on the IP visit counter service. And now I can go over to Goland and work over there. So, okay, I'm right here in Goland, the JetBrains IDE for Go. We can make sure I'm on the right configuration and I can see the resources that we just saw in that diagram. Okay, and you can see this IP visit counter and also some other microservices from that little diagram. So now let's take a look at the code, see what it does. Take a look at the main functions. So basically, it's a little Go application which is Go. We have a little function in order to set up the connection to the Redis service, because this microservice uses the Redis service deployed on the same cluster. Same with Kafka. Then we have a configuration for this application. And a little function that loads that configuration from environment variables. This is a function that handles the HTTP requests that reach this application. And then there is the main function that starts application, sets up, loads the configuration, and then starts listening to incoming requests. Okay, so in this IDE, I already have MetalBear installed. So I can see this little MetalBear menu and this little MetalBear icon. And basically, I can press this icon in order to enable or disable MetalBear. I guess right now it collides with the Zoom toolbar. So never mind, it's already activated. And that means that when I run or debug my application, it's going to run using MetalBear. Okay, I already have a couple of breakpoints defined in here. I have a very simple MetalBear configuration, mostly for setting the target I'm going to use, and the other values are actually just the default values, I think. So now I'm going to hit the debug button and start debugging this application. Okay, and we hit the first breakpoint, and we can see that the first thing the application does is to load the configuration. Let's step into that and see what it looks like. Okay, we see that the application uses Vipers, which is a Go package, in order to populate the configuration fields from values it gets from environment variables. Now, I don't have any of those environment variables defined on my machine, on my laptop, but still when the application reads those environment variables, we can see right here that it worked, and the application got values from those environment variables. And by now, we know that the reason it worked is because behind the scenes, MetalBear fetched those environment variables from the target in the cluster and made them transparently available to the application that is running right here on my machine. Okay. We can see that this next thing that application is going to do is to use one of those values of the configuration as the path to read. And that path is /app/response.txt. We can do a short validation and see that I don't have this file on my machine, but of course, when the application reads the file, it works. There is no error, and the application gets data. And of course, the reason is because the content of this file was read remotely by mirror_d and made available to the application. Yeah. And then the next thing the application does is to set up a connection to Redis and to Kafka. We can look at the Kafka one, and we can see that it uses another value from the configuration, Kafka service with this port as its target, with this topic from the configuration. And now, of course, you can see that this host, this address is not something that will ever be available for my machine because it's like an internal name. It's an internal host address. But my application is able to create a connection with this address because both DNS resolution and the outgoing connection are made remotely inside the cluster. Okay, so the next thing the application does is starts listening to requests, like defining the web server and start listening to requests. So I'm just going to continue and let the application do that. And over at the output tab, okay. Yeah, and now I can generate a request, and notice I'm not generating it to my system. I'm setting the request to the remote service that is running on my cluster. But nevertheless, it's hitting my local breakpoints, even though, yeah, it's actually sent this request to the cluster. And then I can step through my code and see how my code handles this request from the cluster. I can also make changes to my code and see how my changed local code handles original requests from within the cluster. Okay, I'm going to continue this. I think we're almost out of time. So I'm just going to quickly mention that right now I'm running in mirror mode, which is the name-giving mode of mirror_d, which means that traffic is duplicated, so requests are duplicated, and this is actually the remote application that handles those requests, and my local applications actually just gets a copy of those requests, and the responses that it sends don't reach the client. In this case, I was the client with the curl command in the terminal. But there is also a steal mode in which basically mirror_d steals the traffic for me, and only my local application gets the requests from the cluster and also handles them and replies to them. And for that, there is also a filter feature where I can filter requests by headers or by path, in case I only want to steal some of the incoming HTTP requests for an application. Okay, I think that's all the time we have for the demo. So really quickly, I'm gonna get back to the presentation. That was a quick tour through the internals of mirror_d. Murdy has a lot more interesting implementation details and also cool features that I didn't have time to show you. So if you're interested, you're welcome to read more on our website and also take a look at our code on GitHub, because it's of course open source. And now that you've seen how easy it is to use, I hope you'll try it out and let me know what you think. I recommend joining our Discord for live Murdy support from the community and the team, and also just to chat. And if you have any questions or want to talk to me, please feel free to contact me. Yeah, either through our Discord or in my email. You can now see on the screen. And that's it. So thank you very much for your attention. Thank you, Cheryl, and bye. I just want to say I can't hear what's happening in the room at all. So if there are any questions or anything for me, can maybe unmute yourself or let me know via chat.